Hey everyone. I hope this all is set up. Yeah, I think so. Let me know if you can't hear me. Thanks for joining me. Again, sorry about last week. My car died a sad death, and I had to take care of that. Hey, yeah, that was super emotional. I wasn't in any place to be streaming. And then the week got away from me, so we're going to combine. But actually, given the themes of the last two episodes of Star Trek, it actually works out quite well. There's a ton to go into. Friends are here. Hey. And we are going to get into it. So I have some buddies who joined me to be my biology backup squad, depending on how ugly this gets, because I need biologists for this. The entire time I was watching it, I was literally just like, damn it, Jim, I'm a physicist, not a biologist. Why are you doing this to me? It was terrible. So, yeah, let's get going. I'm going to go in chronological order. Yeah, whatever. Chronological order through the episodes. There's a ton of stuff to discuss at the end of episode 5, so stick with me. I'm going to kind of gloss over things, and then we'll get into the details of, tardigrades and that fun stuff, because, yeah. But anyway, we will get going. So, if I don't screw this up, first shot from episode 4, I went, whoa, we're on a planet and lightning storms and rocks, and no, not in the slightest. It purely had to do with replicators, and which was kind of cool. I actually really enjoyed it because there's a handful of things that we talk about in Star Trek that we try to figure out the science of, and it's like warp drive, transporters, and replicators are the things that always comes up. So now we get to see a replicator in action, which is pretty sweet. Interesting thing that I enjoyed from this was that this was the shot that we got, and Michael gets a Starfleet uniform. And for those of you who have watched too much Star Trek in their time, you will recall that non-Starfleet officers are banned from replicating Starfleet uniforms. So this means she's allowed to be a Starfleet officer, which is kind of cool. And then here she had like a holographic mirror, which I love. She actually said like holographic mirror. Now this got me thinking though, that holograms and the EMH, emergency medical hologram, is isolated. If you remember, you have like the holodeck, and then you have the EMH in the medical wards. And he couldn't leave. That was a big part of Star Trek Voyager, was having the Doctor be mobile. So we're trying to figure out how everyone would be equipped with their own holographic projection in their rooms. Seems simple enough that you go, oh, Star Trek has hologram technology, so let's have everyone have hologram mirrors. That's awesome. But it's a little bit different to how it's been done in the past. So we have our holographic imagers. Those are the things that like the Doctor in Voyager used to take pictures of people, like 3D pictures, and project it. So I thought that this could kind of be that kind of technology. But then you would require like 3D cameras all the way around. So I thought it was maybe just set up a bit more like your EMH. Like you have holographic projection technology within your own room, and can't leave the room. It's just mirrored. But yeah, worth thinking about. I know, we're doing baby steps. There's some cool science here that we got to figure out. And holographic mirrors. That's not as easy as it seems, given the way Star Trek has presented hologram technology in the past. Maybe not solid like EMH. I thought that as well, but then they said holographic mirrors. So I was like, well, if you're going to call it a hologram, then we're going to have to go with it. And it was pretty realistic, which was kind of cool. But yeah, maybe it's not solid. Maybe it's just a reflection. But then how is it just like the communication technology? In that case, that's fine. We use that all the time. But it didn't look like that. So anyway, fun to think about. Sorry if I'm breaking things already. And then moving swiftly along, We get the Klingons doing some cool art, and I mostly just wanted to put this up here because it was cool, and Klingons. And I don't get to talk enough about Klingons in this episode, so I'm going to include them any way I can. But the cool thing about this is this actually reminded me of some of the augmented reality technologies that are coming out, where we have you're able to do art and in VR, and I don't know if there's any AR art programs out there, but I mean, we're getting there. So that's kind of cool. I love finding things that like Star Trek has that seem futuristic, but actually we kind of have that technology, which is kind of cool to think about. So yeah, I just threw that up there as like AR style art that were basically already there. And then, all right, here we go. And it begins. All right. So I pulled screen caps. There's obviously lots of points in this episode, and like I said, we can talk about stuff I miss at the end. I try to reference it as much as possible. I've got notes down here that I'm trying to refer to. But they bring up the big old beastie that they got from the previous episode, in episode 3, which if you've watched 4 and 5, there's a ton in there. So you got to kind of rewind and go back to the beginning of episode 4, where, oh, thanks for hosting me. You got to go back to the beginning of episode, or the end of episode 3, and remember what happened. And that ended with them just finding this beastie. So we have to figure out, hey, how's it going? We have to figure out how this is all going to work. So it starts with finding this creature that's in the, my Glasgow's coming out, call it a beastie. That's imprisoned in this like war room, which Starfleet I have feelings about, but they're kind of addressing them, which is cool. And they start by describing it. So he brings Michael in and he says, all right, I need your help with this. This is why you were brought along. Start looking at this. And she does. I really want to pull out some BSG references, but spoilers. And so she says, this creature is like a tardigrade. Did I say that right? Tardigrade. And that's all well and good. I think people who know what tardigrades are lost their mind. Someone like me went, well, I think I've heard that before. Uh-oh. This is going to be biology. Oh, thanks, Cypher. So this is a bit of a tricky one. I looked this up with the help of friends. Hey, no worries. Thanks for stopping by. I ran this by friends who are sitting in this room right now, in the chat room, and asked about tardigrades. A quick Wikipedia search, which I feel like the writers did. Ooh, Cypher, yay. Oh, I'll be at TwitchCon too, by the way. I'll say that at the end, but you're running through. Hopefully we can hang out. Yeah, so tardigrades, tiny, tiny creatures, kind of look like the images that they have of them, but like less than a millimeter. I found about half a millimeter is as big as they get. They're water-dwelling, 8-legged. That looks like it's 6 legs. And they're found everywhere, and found in very extreme environments. So, debated this a lot. They count as extremophiles and how that term works. So people who are interested in astrobiology or finding aliens, may have heard the term extremophile, and many different species too. Yeah, thanks. May have heard the term extremophile in reference to finding aliens or creatures on other planets. And this is because when we throw that term around in a casual non-biology person sense, we are throwing that term around meaning that we are trying to find creatures, species that can live in extreme environments is basically the loose definition of that. Me not wanting to get in any arguments with any biologists because I know terminology can get tricky at some point. Damn it, Jim. Why are you doing this to me? So one of the things I read was that you can't really necessarily consider these guys extremophiles, given they just can live anywhere. They're just super resilient, really, is more a definition of that. So again, we're talking about tardigrades in the real sense. So back in the day, and I'm going to come around to this at the end, but if you guys can't hang around for the entire time, when these were being studied, they thought that there was a high percentage of what they called foreign DNA in them, which naive Star Trek nerd interpretation of this is mini Borgs, that they just assimilated DNA from other species and incorporated that in. And so everyone was like, oh, that's really cool. And they're super resilient and all this sort of stuff. I was reading like they can survive. I'm glad you like that analogy because I'm using that. They can survive in the vacuum of space is what I read, that basically they were thrown in a vacuum to see if they could survive. And they do kind of hibernate and shrivel up. And one thing I read, so they are water dwelling, and I think that's one of the big important things. But then when you see these schematics up here that they throw up, there's like bones and lungs, and even me was like, well, that looks like a invertebrate creature, but you've got like bones and organs that I'm pretty sure don't work. But we'll get into that. So anyway, tardigrades are introduced. Tardigrade-like thing. We call it Ripper. The problem is that main thing is the water dwelling. And they said it was tardigrade-like, which is all well and good, but then they continue to call it a tardigrade through the entire thing as if it was that species' name, like the name of that species, which, so if they'd stuck with it just being tardigrade-like, that'd be fine, but then they continue to just say that it's a tardigrade, so we'll play around with that. But anyway, we're going to take a break from this. Oh, that's a real one. Real one? Picture of one? Artist rendition of one? Is that a real picture of one? I think it is. Google. All right. We're going to go to a happier place for me, and that's talking about dilithium and physics, because I can do that. That's a comfort, happy place. So if you remember, there was a dilithium mining colony that was being attacked by the Klingons. Talk about dilithium super briefly, and actually it was a really nice comparison because I was reading what other people were interpreting about the spore drives and all this stuff, and I think someone said, oh, it's totally fine because like we threw out crystals like back in the day to explain warp drives, so why not spores? And I was like, vacuum of space, species, evolution, organic things, different. But indeed, Star Trek came up with the idea of dilithium crystals as a way to explain a lot of the technology. Now, lithium is an element. Dilithium means in the sort of chemistry sense that you have two of them, that you have a molecule, but lithium is a metal, and metals can't bond in that way, so you can't have a diatomic molecule with metals. So dilithium sounds chemistry-like, but they're getting away with it, which is fine. And in Star Trek lore, because again, we're going back to Erin's happy place where she doesn't have to learn new biology that scares her. It was discovered in Star Trek land in 2049 on Jupiter's fifth moon, which as we count now would be Io, which is one of the Galilean moons, and it's close to Jupiter, and it's the really volcanic one that looks like a pizza. So fun fact. See, we continue to learn things. And it's used for warp, primarily, in Star Trek. And it's really rare, which is why you have mining colonies. They reference dilithium mining colonies in Voyager, too, as well. And I think Next Gen, there's some references to it. Now, the Klingons are trying to find dilithium. Their dilithium stores are running low because they need it for their replicators. Their food rations are running low. And they mentioned cloaking technology. I was trying to figure out if that's what they were needing the dilithium for. I'm not sure because we've never talked about dilithium being needed for cloaking. I don't think. Correct me if I'm wrong. But they just needed to go to the ship to get the cloaking technology, the old blown up Starfleet ship, to get the cloaking technology, and they needed the dilithium for the rations, which is kind of where I was going with that. So I think we're okay with that, but we got to talk about dilithium and warp and some crystals, so that's nice and calming and soothing for a physicist like me. And then they talk about what happened to the Glen. So they said that it was destroyed by a Hawking radiation firewall. And I went, whoa, pause. Wrote it down. So Hawking radiation firewall is a thing, super theoretical thing, still a thing. And I'm going to break it down real fast. Hawking radiation has to do with black body radiation. So what is black body radiation? This is the idea that light can either be emitted by something, we like emit light, like we have heat, so we emit in infrared. It can be absorbed, so we absorb light. We get sunburned. We absorb radiation from light, and you can reflect light. So someone with super pasty Scottish skin reflects light to a sort of blinding degree. And so you can absorb, emit, or reflect light. Now, black bodies don't reflect any light. So they're like what we call a perfect black body is an object that just absorbs radiation and then emits it. It doesn't reflect at all. And you can learn some physics from that. So depending on, it will emit radiation in a spectrum. Where the peak of that spectrum is will tell you how hot that object is, which is kind of cool. This is kind of like physics 101 type stuff. And then Hawking radiation takes that in a really twisty, angry step further. And I'm doing that intentionally because of the twisty things that happened to people when they ran into a Hawking radiation firewall. And essentially, Hawking radiation is something Stephen Hawking came up with in conjunction with Zeldovich, so it's sometimes called Hawking-Zeldovich radiation, and it is black body radiation from a black hole. Now, what does that mean? It's pretty theoretical. It has to do with quantum effects of particles falling into a black hole. So the idea is that as particles fall in, they will get kind of shredded, and in a quantum land of things will emit this radiation, and eventually it will shrink the black hole over time. Super theoretical. One of the things that comes out of this, if you play with the math and the quantum physics, which is scary and nightmare-inducing, is that all this matter's falling in. Quantum shreds it, so the physics shreds these particles, and then essentially what happens is you get these entangled particles, one falls in and one goes out, and when that happens you get a big release of energy. And so there's like at the event horizon of the black hole where all of this is going on, you get this huge amount of energy. We've never seen this, but it would be nasty and dangerous, and it does kind of violate Einstein's equivalency principle. I saw someone equated it to just saying like, yeah, there's like a quantum chance that a brick wall is going to just appear in front of you and you'll walk into it, but no. And that's kind of the issue with the firewall. Hawking radiation firewall is that you can make it work, but it violates some pretty fundamental physics that we have. Like, it's not just gonna be there. So it's weird. Theoretical physics kind of can go in different directions and can get kind of tricky sometimes. The cool thing is I've got to pitch this because it's been gravitational waves celebratory-thon for me. Since I worked with LIGO, name drop, and they won the Nobel Prize last week, and they detected, they did a joint electromagnetic neutron star collision and gravitational wave detection from that. So big deal, lots of science. Message me on Twitter if you want to learn more, because it's amazing. But the cool thing is with this Hawking radiation firewall theory, you can explore that with gravitational waves, is all I'm saying. Because black holes collide, we detect those now with gravitational waves, and you would be able to see if there is a radiation firewall there based on just the warping of space-time and the energy coming off of it. Won't go into any more detail, just they threw that techno term out there. That actually means something, so I wanted to talk about it. Okay, so moving on. They jump and with their spore drive to a point in space. And I have things to say about that as well. But they talk about it like jump drive. So if you've seen my talks in the past on faster than light travel, we have warp drive, jump gates, and jump drives. And what they're doing is effectively jump drives, and they refer to them as such. The idea that they are able to somehow, and this whole biology spore thing is a different way of doing it than has been done in the past. But you take one point, you go to another point, you bend it to you, you jump and you unbend, and that's your jump. So you disappear in one place and appear in the other, and you've effectively projected yourself through space-time by bending it toward you. Or traveling along a spore network, which we still need to get into. So they did throw out the term probabilistic jump, saying that the more often it happens, the more likelihood there is an accident, which is a little bit tricky to say. Doesn't make things super easy if we're going to go in that realm of probability drives, because we saw that somewhere else in Hitchhikers. And compounding probability makes for fun times. I'm not even really going to get into it, because I think they're throwing enough out there for traveling through our universe that if they're going to say the term probability drive and that you've got a problem, the more times you jump, the more likely you are to have an accident. I don't think that's a probability drive. That's just saying the more times you jump, the more likely you are to have an accident. So we're going to leave it there. They do have this cool scene where they jump into a solar field and then actually try to crawl out of it. And a lot of times when I talk about like space-time and gravity, one of the things trying to describe is this idea of a gravity well. That if you have a really massive object, you have to be able to crawl out of this well. Launching spacecraft requires a ton of like fuel and energy to climb out of this gravity well. And they did some kind of cool visuals with this, with them being trapped in the gravity well, where you can see the ship kind of struggling to escape. And they're like, oh no, we're too close, we're stuck in it. And so that was kind of cool. They jumped into the solar field. Some nice solar flares. Obviously, we've observed the sun a ton of times, so we have some pretty good imagery of it. But they got it right. Nothing here is super screwed up. This looks like a pretty average star. Looks like our star. And you can see those little tendrils that are coming off are going in an arc fashion from one point to another point. That's what happens on the stars. Again, we have enough to talk about. I don't need to go in detail on it, but real quick, all that's going on is that we have, that's what sunspots kind of look like if you get really close, depending on what wavelength you're imaging in. And like you can see kind of just under the disk, kind of down and to the left from the disk, you have this one nice arc. And that's kind of like magnetic field lines. And you have solar particles that are following those magnetic lines. Now, as the sun goes through its time, you may have heard of the solar cycle. What happens is those field lines, those sunspots, those paired sunspots, I use the analogy of a rubber band. So it's kind of like you have a rubber band between the two of them, and the band is twisting and twisting and twisting and twisting, and then eventually it just bursts, and that's where we get solar flares from. And you can see that coming. You can see a solar flare-like thing from behind the ship, and they look like that. Now, usually when we image the sun, an image like that would be a combination of visual and some other ones, but it's close enough and it looks cool, and you can see some sunspots on there. So we'll let that go. All right. And I'm not here to tear apart Star Trek. I'm just upset that I have to learn biology. Hey, Hot Snot, thanks for joining. Yeah, I'm just upset I have to learn biology. Sorry, guys. But I'm learning, and we're doing this. So, onwards and upwards. Twirling into the future. All right, what's next? Oh, Klingons go to retrieve the technology from the ship. Cool few things here that we got, and thanks. I like to think maybe after Star Trek, it certainly is going to be better than it was when I started. So, cool thing with this scene here is that we have a blown out Starfleet ship. Obviously, there's it's a vacuum. You can see it's iced over, which is valid because all the water in the atmosphere would just freeze. So that looks how it should look, which is cool. And then the other cool thing is, if you remember from the first episode where she first goes to the anomaly that we now know as Klingon thing, but she goes to that ship and she lands and her boots connect to it. And I was like, oh, it's like magnetic boots, but you have to make sure that the metals are the same, whatever technology you've got. And they are, because the Klingon's using the same thing. So we're good with that. And then I got really excited when he did this. He put the little thing on the ground, sealed the windows, and started to pressurize the room. So, yeah, if you want to breathe, you need air pressure. You need air pressure for lots of reasons. The reason space is not a happy place for humans without some sort of suits or anything like that is simply because it's a vacuum. And when there's a vacuum, you're not going to get any air pressure, which means it's going to be a really cold temperature. And you aren't going to be able to breathe, because that's how we're able to breathe, is that our diaphragm manipulates the air pressure. And yeah, so if you want to breathe, you seal the windows, but you got to bring air with you. And they did, and they pump it in there, which is awesome. So yeah, that got me kind of excited. All right, so moving on. All right, here we go. All right. Again, I've seen 4 and 5 now so many times. I'm trying to remember what they're introducing. This is the first time they introduced the concept that their tardigrade thing they call Ripper, right? Is able to communicate with the mycelium spores. I think I said that right. I can see why writers come up with technobabble, simply because I don't know a technical term in biology at all. I'm so under my depth. Damn it, Jim. I'm a physicist. All right. So this is where they introduce the concept that Ripper can navigate through the galaxy using those spores. Yes, technobabble. Love it. I am using that. So we have a picture of the galaxy, we have a picture of Ripper, and we've got a picture of these spores. And the idea is that they're somehow entangled, which is, we kind of got into in episode 3, this idea that you could possibly use some quantum entanglement with the spores in order to travel through the galaxy. But this creature, they call it tardigrade, so we're going to go with that. This tardigrade-like thing called Ripper is in some symbiotic relationship with these spores. Now, symbiotic relationship means they're each getting a benefit from that relationship. Not sure what the spores get out of this. Maybe we will learn, but not obvious at this point. So the Ripper is able to follow this whole thread of spores and see this whole thing. And I have a long discussion about this coming up shortly. But they say, okay, possibly we could hook Ripper in, and then this creature will be able to navigate the spores and carry us through. So kind of loosely in the way warp drive uses space-time to propel us. Maybe this creature can propel us through this spore field thing that's happening. good luck. But they plug it in, and he starts to see the whole map kind of pop up. Now, what they're looking at here, you have the yellow, orange, white spots, red spots. I assume those are stars, and that the sparkly, glowy purple bits are the spore network, I'm assuming. If that is the case, that's a pretty small fraction of the galaxy, which makes sense, because they're kind of just concerned with dealing with the Klingons and that whole situation. So you're only care about your portion of the galaxy, which is fine. That's all solid. We're good with that. I don't freak out in that circumstance. So this just looks like you're looking at a handful of star systems, a small portion, the edge of Federation space, the edge of Klingon space. Okay. They're completing that map. They've got this spore drive network that they're going through, and they're able to say, okay, if I want to go to this star system, then it looks like, there's a network to that, and okay, we can direct this creature to get us from one point to another. Okay, we'll go with it. Now, I'm just going to interlude between the two episodes because I have more to say about this, but we're going to move into the next episodes. But before I do that, you're going to have to give me two Geek Out moments. The first was this. Is this Kirk? Is this Kirk? This looks a lot like Kirk. When he came on the screen, I was like, is that Kirk's dad? And I was like, wait, no, the timeline. Is that Kirk? Given like between Shatner and Chris Pine, like it's very Kirk-like looking. He's got the rank of lieutenant, so maybe. I just have to put that out there to stake my claim. Like I said, I don't watch After Track. I kind of try to just live with the series that I've got. I'm staking a claim on that one, and he shows up later too, but like, just putting my stamp on it. We can move on. I like to do those things. And then telescope, pretty telescope. I like to think that people have telescopes as these nice, momentous, important things that we all have. That was kind of touching. And then too, the story that happens later with it is really sweet. All right, so if you haven't seen episode 5, we're gonna go into that now. But we'll just jump right in. We're gonna start with this. So they're going through the different maps. The fact that this ship, Discovery, is jumping, using this spore drive, using a spore jump drive, which they say all the time. Again, jump drives. I think of like Battlestar Galactica, pulling space-time to you, jumping, unbending. They're using it in a weirdy, quantum entangly, webby sort of way that allows them somehow to jump from one point to another. I'm to be continued. We're still working on it. But they bring up this picture, and they're talking about all the different incidents that they helped prevent or they were involved in. And they're talking about systems, and they bring up star systems. And like I said in the previous ones, they were showing like it looked like it could be the galaxy, and then they showed the galaxy and the tardigrade. And at some point too, Captain Lorca says that they're able to jump throughout the universe. Now, when we were talking about this in episode 3, I promise I'm not as stressed out as I seem about this. I'm just trying to figure out a way to explain this. Let me see. Hang on. All right. So in episode 3, we were talking about this, and we said that it was really difficult to have this spore network that would be able to go through just the galaxy. Like, it would have to be through the entire universe. And hang on one second, sorry. Yeah, I don't know if I have any mods on there. Okay, so we were talking, if this spore network would have to go through this entire galaxy, it would have to go through the entire universe. So that makes things very difficult. And the problem is that he's also throwing around universe, and he's also throwing around all the things. That's why I made a video on how to explain the cosmological address and why people get so confused with it. And it's exactly because of series like this. It's because they throw around star systems, galaxies, and the universe like they're interchangeable, and they're not. And it's very confusing. So we don't want to deal with that too much. All right, so I'm having a little bit of an issue with how the writers are dealing with this, and just because it confuses so many people. They don't know the difference between star systems, they don't know the difference between galaxies, they don't know the difference between the universe because they're used interchangeably. Now, if they're able to jump on this spore network using this creature, then theoretically they could jump anywhere in the universe. And Star Trek tends to take place just in one galaxy. And Star Trek does take place just in one galaxy. It tends to take place in one quadrant of the galaxy. And even when they're talking about the Klingons, you're talking about even a subsection of that and down to individual star systems like we have here. And that makes things confusing. And when it's used interchangeably, it makes people like me have a hard time dealing with it. But it's okay. It's okay. We're moving on. We're good. We can handle it. So as they go on, let me see. I want to make sure I get this all right. All right. Yes. Captain Lorca gets kidnapped, which was interesting and cool. Not cool for him, but they're trying to trace it, and they say the Klingon, was this before or after? They said the Klingon warp trail has dissipated, so they can't follow them. I think this might have been before he disappeared. Now, I've talked about this in the past, what we mean when we say warp trails. Now, there are some technologies that are used in Star Trek, and one of them is called tachyons. Tachyons are also theoretical, and I think I've mentioned them here before, but what they do is they are particles that, whereas normal matter bends space-time down, tachyons invert it like that, and you can use that to make warp drive and coast on them. And if you have warp drive, you're using tachyons in order to build your warp bubble because you're able to bend space-time how you want with them. And the idea is that as you travel through, you would leave behind a series of tachyons is kind of how it looks like. You would leave behind these like bumps and ridges in space-time that would allow you to trace if someone had been using that. So that's kind of cool. Now, so when they say the warp trail is dissipated, basically they're saying is these little tachyons, these little inverse bumps in space-time have flattened out. So you can't track them anymore, which is kind of, that's how I interpret it anyway. And I'm good with that. All right. And next, again, just geeking out. I've got to geek out about this. I was so nervous when they introduced Harry Mudd as a character, and like, I was like, oh, like those episodes in the original series are so archaic, especially towards women. Like, it's really bad. Question from Swizzlemania: how long are tachyon bumps supposed to last? So the idea is that if you so you build your warp drive, and then as you travel through, the idea is you sort of leave a wave trail, like a wake behind you, kind of like gravitational waves. And they would dissipate at the speed of light effectively, but they'd be radiating out. So they would be losing energy is kind of more the idea. So you could detect them after a period of time after they've started to spread out and dissipate, but they'd get smaller and smaller and flatter. Cool. Yeah. I hope that made sense. Thanks for asking. That was a good question. So yeah, I was really nervous about Harry Mudd being in here for lots of reasons. New series, referring to old ones, that sort of thing. Oh my God, he freaking nailed it. If anyone knows Rainn Wilson, just please give him a high five for me. Like, that was amazing. I literally like exclaimed out loud while I was watching the series. I was like, holy crap, he got it. This is so good. So he was so good. Super appreciated his acting there. But I'm not just geeking out over that. There is a reason that I bring him up. But before I get to that, they did also talk about, so I was looking up stuff for this episode, and they've started introducing timelines. So I guess this is in 2256, if someone can confirm that. Memory Alpha was throwing that date at me, which made me think that the guy before that I thought might be Kirk, I thought originally it might be Kirk's dad, and then I was like, well, if this is 2256, then definitely Kirk would be a lieutenant, because we have Mudd here, and that's only like 10 years later that he meets Kirk. So anyway, just Star Trek geeking out. But Mudd is talking about this woman that he fell in love with and that he bought her a moon. And I went, ho, all right, something I could talk about. Because there's a thing called the Outer Space Treaty of 1967, which some people may have heard about, or at least heard the implications of. And this is the idea that, well, it came around in the mid-60s. In 66 was when they started writing them. And the U.S. and the Soviet Union submitted drafts to the United Nations, and they were reviewed and brought together and implemented, and kind of a big deal because we were in the Cold War at the time. And also, remember, Star Trek is airing as this is happening. So people are starting to think more about exploring space and the implications of that. And it's kind of cool how much the space race and like Star Trek was influencing people's ideas about space culture. And so they came up with this Outer Space Treaty, and the main idea was that no one can put nukes on the moon. That was the main reason for it. And however, fallout from that and further discussion led to the idea that we essentially can't claim sovereignty over any object in space. Now, this came out in 1967. So no one can own a planet. No one can own a moon. No one can buy a moon for their girlfriend, is basically where that comes down to. But the cool thing is that that's actually started to change a little bit, because as we're learning more about space and as we're starting to explore it more, we're unable to totally hold up to that. We have to adapt it. And people are starting to get degrees in space law, which is awesome. And the whole concept is we're starting to learn how to mine space and try to get elements off of things like asteroids. But the Treaty of 1967 says that you can't own an asteroid. So how do you do this? And a handful of things that have come up. One of those is that they're sort of amending this idea of owning objects in space, in that if you want to mine an asteroid, you can own your mining facility and you can own whatever you extract, but you can't own the asteroid itself, which then leads to the idea of space piracy and space sabotage, which are now actually things. So buying stars as gifts for people is a scam. Lol. Yes, lol. It's not a scam, but it's not valid. It's sweet, but you don't actually own it, according to the 1967 Space Treaty. Sorry. Still kind of fun to think about, though. And I had to throw that in there because Mudd was awesome, and I couldn't get through this without talking about how cool he was in this episode, and talk about owning things in space and spice piracy. So the next one that I wanted to talk about was, again, trying to map out exactly where they are and what's going on. And it's starting to come together. I did look up to make sure that this was right. But if you can look carefully without having to get too close to my face, you can see there's Deep Space K7 there. Hardcore. I mean, that's the trouble with Tribble Space Station. So on the edge of Klingon space. Awesome. Nailed it. Great Easter egg. Totally in love with that. The other Easter egg that it wasn't even an Easter egg because you didn't have to find it at all. Enveropenta. Yeah, there's like 3 or 4 ones in here that were just, gave me the feels. One Easter egg that can't be called an Easter egg because it was in your face, was when Saru was going through trying to figure out how to be a good captain. and he pulled up the best captains in no particular order. Pretty sure he said in no particular, the computer said in no particular order, because I can only imagine the writers sitting in a room being like, okay, let's rank the ones that we've got, and someone went, no. We don't want to deal with the fallout of that. But it was on that list was Archer, Christopher Pike, and Giorgio. And then I didn't recognize the other two. I didn't have time for. April from animated series. Yeah, right? Seriously, like they really love it. Yeah, that was it. Thank you. This is why I talk to you guys. Okay. Another shout out. Did anyone else get this? I think that this was intentional when they're torturing Lorca and pry his eyes open, and then this is what they show. There are 4 lines. Yeah, that's definitely what I thought. There are 4 lines. All right. And then they're trying to fight the Klingons. Again, I try to just pull out when they do actual like Star Trek or science references. One thing was that they jumped near the Klingons. They said, we're hiding at a distance of 0.7 AU. I was like, is that a feasible distance? Yeah, it is. Basically, it's the distance from the sun to Venus. So as far as our solar system goes, it's on the smaller end of the scale, but it's not insane. So a 0.7 AU, you're close, but you could definitely hide. So we're good with that. And now, to conclude, to spend the rest of the time concluding, tardigrades in space. We've got to talk about these guys. All right, so we established that tardigrades on Earth are super tiny, invertebrate, water-loving creatures. There is some allusion to that in the series because Ripper's sucking down water a few times when you see it. They also talk about the idea that you can use horizontal gene transfer. And as much as I would like to hand the camera over to Eric, I don't know how to do this. So we are going to power through. But the idea of horizontal gene transfer, as far as I understand, and the 2 geneticists that I know of that are watching this can jump in at any point. Horizontal gene transfer means basically that you're able to transfer genes from species to species. Is that a good shortcut for saying that? That you're able to incorporate genes from other species that can be done through viruses or other stuff like that, that you can share DNA and genes somehow. I hope someone's furiously writing a response. Yep, not vertical via parents. Thank you. Okay, good. Then I interpreted that correctly. Excellent. They did say that humans in the show, they threw out that humans, see you, Cypher. Thanks for hanging out. I'll see you at TwitchCon. Woo! They did talk that humans share 50% of their DNA with tardigrades. Is that correct? Yes. So one of the things with tardigrades on Earth, they said that we've studied, that we're trying to figure out, remember that there's a lot of like foreign DNA in them, but we also share huge amounts of our genes, our DNA. I'm trying to remember my analogy. Hard to say, those numbers are meaningless. Good. All right. They're almost meaningless. Yep. Thanks, Mohammed. That's what I need to know. So they said that we can perform a lateral gene transfer or horizontal gene transfer from the tardigrade to humans in order for a human to act as the sort of ship driver thing. I was thinking of Farscape when they said that. I think Farscape. Yeah, it's been a while since I watched that. I think it's Farscape. Sort of creature driving the ship. And the other issue is that, so a lot of the things that they're using with this tardigrade in this show is the fact that it can survive in space. You were thinking Ket when they said that. Nice. they can survive in the vacuum of space, which we kind of talked a little bit about. The idea that we've taken these little tiny less than half a millimeter tardigrades that we have on Earth and subjected them to vacuums, and they've survived. They also expel a lot of their water. I think I read down to 3%, maybe correct, and shrivel up just like this guy did. So the writers did a pretty good job researching what cool things tardigrades can do. They can also be subjected to huge variances in temperatures. I read down to 1 Kelvin. And space itself is at 2.7 Kelvin. So they could survive the coldness of space. Space is a vacuum. And we're all good in there theoretically. So where is it falling apart? Well, first of all, like I said, the schematics that they show of the tardigrades have them look like they have a bone structure, which would make them vertebrates, which is a problem because they're not. They also seem to have lungs, given the fact that they scream in pain and wail, and it looked like they had lungs in the schematics of those. That makes that difficult. And then this is actually one of those times where physics and biology does kind of naturally meet instead of being forced together in an angry battle over drinks at Dragon Con. And that is when you scale up a creature, you can't just scale it up. Just because you make it, in this case, thousands of times larger than it actually is, that doesn't mean you can just proportionally scale everything. And certainly in my realm, I was thinking that definitely with surviving a vacuum of space. Now, again, the problem is that when they send it up into space with its little happy spore time, and it was sweet. It was a really cool, it's gorgeous. Look at it. It's a gorgeous scene. It was all shrunken down, and that is how they survive in the vacuum of space, is in that shrunken state. Again, I was reading this on the internet, so experts should correct me if I'm totally off base here, but I read that when they shrink down and expel the water, basically they utilize some type of sugary crystal, a type of sugar that stores the water, what little water is left, that protects it from the vacuum of space, so it can be rehydrated, essentially. Then the whatever sugar crystals are, and I say sugars in the chemistry sense, not literal sugar that you put in your coffee. If you're a monster. That you could dissolve these sugars, whatever they are, that are storing this water, and rehydrate it when it's in a water-happy environment. Having it rehydrate, as it does here, in the vacuum of space, would mean that is pretty impossible to do. So, I'm glad you appreciated that. And the other thing too that I was thinking of is we are starting to discover things that can survive in the vacuum of space. One of the cool things that we found is that on the International Space Station, I know I've mentioned this before, the International Space Station, we've discovered bacteria that can survive on the outside of it for a long time. And it's fine. And again, we're also trying to study other weird creatures that can do this, but it's a scaling issue. If you're going to make something really, really, really big, that's going to have a much, much harder time surviving in the vacuum of space, because you're going to have more areas that could be potentially exposed to it that are just going to make life pretty difficult for it. So that's difficult. Again, I don't want to tear it apart. It's creative. So I think our official statement on this. And I do like the challenge. I do like that I've had to learn so much biology from this. All right. A few minutes. Is there anything that I have missed that you wanted to talk about? Let's see if I missed anything in here. From these 2 episodes. Any questions people have? There's just a handful of things that have been thrown out as we go. They're talking a little bit more about the shields. They talked about cloaking technologies and needing a dilithium processor. Again, I think that was more for food. Oh, the idea of using this as a superconductor. Biological superconductors have been brought up as the whole idea, if you hear about biological superconductors, is just this idea that like possibly biology is able to have a higher processing speed than like chips can. It's cool. It's fun to think about. I interpreted more when they were saying that this is just one big superconductor as that it's on a network of spores in space that we use to travel places, and we're good with that. Do we all kind of agree that they used spores to make it happy because that was its happy natural environment? They did say something about the fact that these spores exist in hyperdimensions, I think. Still doesn't explain, though, because if they exist in hyperdimensions, still doesn't explain how they can survive in a vacuum. Subspace. Thank you. But if they exist in subspace, then we wouldn't be able to put them in jars and pour them on tardigrades and interact with them in laboratories. So that makes it a little bit trickier. So subspace, I'm going to take that as a genuine question as opposed to just an exclamation. Subspace being this idea that we have our space-time and that subspace is the stuff above or below the sheet. So again, when you have a wormhole, that's punching through subspace. When you're bending space-time around you, you're in a bubble of subspace. That's the layers between the layers of onion. That's our subspace that we talk about. So again, when I had students in the past go, what's in the box? What's under the sheet? It's the stuff under the sheet or above the sheet. If we have layers, like brain, multiverse, membrane, universe, then that's the stuff above or below. Our hyperdimensions are another way of putting it. Starts to get tricky. Can there be matter in subspace? There can be. We wouldn't be able to access it in our own space without great difficulty. So Performance said the best way to interface with a creature's brain processing power in the 23rd century is by nipple clamps. Good to know. Correct. As far as we know. Or scary needles. Those look like scary needles. Scary, evil needles. Yeah. I love that. All right, start refining that technology now. All right, I think that's it for me. Any final questions? Otherwise, thanks to everyone for hanging out. This was really fun. I promise I'll be back next week. I think there's another episode next week. Yeah, we're powering through. Bring it on, spore drives. Could be weakly interacting dark matter in subspace. Man. Thanks for coming. I appreciate it. Thanks to everyone for joining. It was fun hanging out with you. Thanks to my subscribers. You can donate down below if you'd like. I have a new episode on demand coming out on Thursday. I'm going to be doing part 1 of Multiverse Theory, which should be really fun. And then I'm also going to be at TwitchCon this weekend on Friday afternoon and on Saturday. So thank you, everyone. Have a good one. Live long and prosper. Catch you next time.